Okay, let's dive right into a really tough engineering challenge. We're talking about building a hybrid cement mixer that's not just good for the planet, but actually good for the business. We're going to walk through a complete technical blueprint here, focusing on how you make it lighter, safer, and, profitable. And really, this is the question, isn't it? Adding green tech is a must these days, but it comes with a pretty big penalty. The irony is, if you're not super careful, the very technology that's supposed to save you money it could end up sinking the whole operation. And here's where the problem really hits home in raw numbers. A standard 400-volt hybrid system, and that's the battery, motor, all the cooling, the protective gear, it adds a staggering 800 kilograms to the truck's weight. That's nearly a ton of extra mass that is not carrying concrete, not earning you a single dollar. And that weight, it translates directly into a financial hit. See, every extra kilogram of truck is a kilogram of payload you can't sell. Even a 300-kilogram penalty can cost you 90,000 RMB in lost revenue. Per truck, per year. That's a total deal breaker. So this brings us to what we're calling the weight paradox. The technology that's meant to save you a fortune on fuel is actively costing you a fortune in lost payload. For your engineering team, solving this paradox has to be priority number one. So the big question is, how do you solve this? And let me tell you, it's not about making a few small tweaks here and there. We need a disciplined, really smart strategy that attacks the problem from multiple angles. Okay, to fight back against this, we need a target, a really clear, specific number. Our engineering roadmap sets a tough but definitely achievable goal. We're aiming to claw back at least 300 kilograms from the vehicle's structural and body components alone. This is how we start to chip away at that 800-kilo penalty. So here's our three-pronged attack to get that weight down. And look, this is way more than just swapping out a few parts. We are going back to first principles, rethinking the design, optimizing the structure from the ground up, and using some pretty advanced manufacturing techniques. It's a complete overhaul. First things first, we absolutely have to protect the heart of this new system, that high-voltage battery. You gotta think of it less like a component and more like a high-energy power source. Safety is everything here, and that means we need a rock-solid, uncompromising protection strategy. Protecting that battery from stuff kicking up off the road, it's a classic engineering trade-off. There's no single perfect material. So what we're recommending is actually a hybrid solution. A tough 3mm steel plate to stop punctures, layered with a 2.5mm aramid fiber composite. Yeah, that's the same stuff in bulletproof vests to just soak up the impact. This combo gives you the best of both worlds: max protection, minimum weight. Now, these are the absolute non-negotiables for that battery system. You miss any one of these and you're risking your equipment, your driver, and your company's reputation. That first point about modal frequency, that's to stop the battery from basically vibrating itself to pieces from the constant rumble of the mixer drum. The IP69K rating means it has to survive getting blasted with a high-pressure washer every single day. And look, a simple stress check isn't nearly enough. We have to simulate years of bumps and vibrations with a full fatigue analysis. All right, next up, we're going for the big one, the subframe. This is where the biggest weight savings are hiding, but it's going to require a complete change in how your team thinks about the vehicle's skeleton. The real breakthrough here is getting the team to shift their entire philosophy. The old way was to just bolt a super heavy, rigid subframe onto the main chassis, which, believe it or not, often creates new stress points. The new philosophy is all about designing a subframe that allows for controlled flex, so it works with the main chassis as it twists and bends. This right here should be the new mantra for your team. It translates to, the subframe is not for reinforcing the chassis. Its job is to coordinate with the chassis, not fight against it. And once you adopt this principle, you can use smart design software, it's a process called topology optimization, to digitally carve away 30 to 40% of the material from the subframe without losing any strength. But as soon as you start mixing lightweight aluminum with that steel frame, you run into a huge risk. The mix of aluminum, steel, and wet alkaline cement slurry, which has a pH of like 12 or 13, it creates a perfect little battery. It's called galvanic corrosion, and without the right protection, your expensive aluminum parts will literally be eaten away. So here's our 3-step playbook to stop that corrosion dead in its tracks. First, physical isolation. We'll use nylon sleeves and washers on all the bolts. Think of it as putting a little plastic jacket between the two metals. Second, a special structural glue that also acts as an insulator. And finally, we seal the whole deal with a super tough, high-tech coating that protects every single nook and cranny. Okay, now it's time to hunt for the easy wins. These are the low-hanging fruit, areas where we can shed a good amount of weight without some big, complex structural redesign. These are the changes that give you a fast return on your investment. And check this out. This is where you get some really satisfying quick results. Just by swapping out these 3 steel parts for lighter composites and aluminum, we can save over 120 kilograms. And the best part? The upgrade costs less than 5,000 RMB and pays for itself in under 6 months, all thanks to that extra payload. It's a no-brainer.
Okay, here's a way to save weight that might surprise you. Aerodynamics. I know it sounds a little strange for a cement mixer, but this quote, which means virtually free lightweighting, is absolutely true. A simple wind deflector on the cab can cut energy use by 2 to 3% on the highway. That's like getting dozens of kilograms of battery range, basically for free.
Okay, last but definitely not least, we have to make sure all this hard work is actually validated and compliant. This is the crucial stage that turns a really cool design on a computer into a reliable, insurable, and profitable product you can actually sell. This is where we move from theory to reality. Think of this as the final gate, the ultimate stress test. Before anyone cuts a single piece of metal, the design has to survive this virtual torture test using computer-aided engineering, or CAE. We're talking a full load rollover simulation, a direct side pole impact right on the battery, a lifetime's worth of potholes, the works. And the rule is simple and absolute. If it fails in the computer, it does not get built, period. So, if you remember one thing from all of this, let it be this balancing act. Every single kilogram your team shaves off is direct, measurable profit for your customer. And every structural calculation you verify, every simulation you run, that's insurance. It's insurance against catastrophic failure and unacceptable risk. So we'll leave you with this final thought. The weight paradox is today's challenge, for sure. But the real takeaway here is the process we just walked through. This systematic, disciplined, creative approach to engineering is the real blueprint. It's the key that will unlock the solutions to the even bigger, more complex challenges your team is going to face tomorrow.